Hello, everybody. My name is Paul Wieneman, and I would like to welcome our next speaker, Yusuf Faisal from Securing Things Limited. Yusuf will be speaking on securing the digital factory, lessons from the field on security challenges from Industry 4.0 or 3.0 to 4.0 and beyond. Yusuf, I will turn it over to you. Thank you very much.
Thank you. And let me share my screen. Can you confirm, Paul, if you can see
Yes, sir.
the screen and more?
Yes, sir. You're good.
All right. All right. So, hi, everyone. Welcome to the session, Securing the Digital Factory. I'll be sharing some of my experience and observations while working for a couple of manufacturers in the last couple of years, where I saw both an Industry 3.0 based organization and those that were going through digital transformation, completely changing how they manufacturers operated. We'll also uncover some why the old playbook that used to work for 3.0 now fails in 4.0 environment, and what new strategic playbook ensures future success for your manufacturing businesses, but also needs some strategic steps that are essential for securing these digital factories. That's where IT meets OT. Whether you are a security professional, engineer, or an executive, hopefully this session will equip you with critical insight into 4.0 security challenges. And I promise I am not going to talk about industrial revolutions, so show you some survey statistics or list down any threats, but rather just simply some sharing to get your feedback on what you all are seeing in your environment and or your region for that matter, in terms of how things are evolving around your manufacturing environment. So moving on. But before we begin, just a little bit about myself. My name is Mohammed Yusuf Faisal. I'm founder of Securing Things, which is an independent IT and OT cybersecurity advisory and consulting firm based out in Hong Kong. I've been with the industry for more than 2 decades. Most of my work experience has been on consulting side, but initial part of my experience was working for an asset user type of an organization. Prior to the current consulting work, I also built GRC PCI OT consulting practice and led several managed security services engagement throughout APAC for previous employers. I've been fortunate enough to serve multiple industry sectors as highlighted on the screen, including different type of manufacturing environment. I also run a weekly newsletter by the name of Securing Things. And I'm also working on a Securing Things Academy, and this presentation is kind of a mini course for IT OT SciSeed program, which is cybersecurity education and awareness transformation. So enough about myself. Moving on, I've divided this into 3 parts. The first part, I'll be sharing some field experience and observation across the manufacturing environment based on 3 different type of manufacturers that I've seen. And then we are going to cover in the second part some key concepts around digital factory and my understanding on these concepts. Just a disclaimer here, the concepts I'm going to present, I didn't invent any of these, but wish I was that smart. Then the third part, I'm going to be concluding the session with highlighting a framework or an approach or a methodology I've used to help craft cybersecurity roadmap for manufacturing organizations. So let's dive in. So if I look at all the manufacturers that I've worked for so far, I can easily divide them into 3 different categories. And they all were at a different stage of IT and OT cybersecurity and digital transformation journey. The manufacturer A, an Industry 3.0 environment, was led by a traditional IT CISO organization. Their usual focus is on perimeter, network security, asset management, compliance, and they had little exposure to IoT or cloud-based technologies. Then you have another manufacturer, type B, which is also a 3.0 environment with some IoT deployments here and there in some factories. But in some of these cases, I noticed that they were responding to a crisis situation. So they were working with IT and TT teams coming together, um, responding to, for example, ransomware incidents or some data breach. Such crisis became catalysts for change in those organizations, which broke some silos between IT and OT and drove collaboration. Some of these organizations were quite large, so they were led by an OT designated OT CISO organization. And then last but not the least, the manufacturer C, which was already on a transformation journey from 3.0 to 4.0. This organization was unlike other two, was led by Chief Digital Officer or the CDO factory, leveraging latest concepts like unified namespace, IoT for real-time insights and automation, and we're going transformation journey. It was interesting to note that they had all the same challenges we have come to read about in many different industry stats, threat reports, and surveys. So each of these manufacturers wanted to identify their current state, which in most cases were ad hoc efforts, no defined strategy, and an unmanaged risk state. And they were striving towards achieving a future state of a resilience and secure business environment with a managed risk state to be achieved. Most of these leaders weren't sure where to start or having internal debates, what should be prioritized on the roadmap. As from previous slide, you can imagine each had a completely different scenario, different type of manufacturing environment, different systems, different vendors, OEM processes, culture, skill sets, and so on.
Yusuf, if I might,
After
there's a in the chat, apparently there's a it looks like there's a studio mode menu that is up on the bottom of the screen there, and it's cutting off kind of the center bottom. I don't know if you see that. Yeah, if we just click the
yeah,
X,
is
there we
it
go.
better now? Okay,
Yes,
all
sir.
right.
And then your voice was breaking up a little bit, but it seems okay now. So,
Okay,
all
all
right.
right.
Thank you very much. Sorry.
No worries, no worries. So after identifying their current state through some initial discovery with all challenges highlighted on the left top corner of your screen in blue, I'm not going to go into details. Um, the only likely suggestions I provided them for each of these type of manufacturer is that you can assume a compromised state because there's too many problems out there in your environment. Obviously, type B was already dealing with the ransomware incident. So recommendations were to stop initial bleed and then look at the long-term health treatment plan for their cybersecurity journey. So do whatever could be quick wins and high impact results, and then figure out what you can do in the long run. So now we are going to switch to some of the key differences in these environments in terms of the way they operated. But before I start, can we have quick poll number 1, please? The question is, how familiar are you guys with the concept of Industry 4.0, digital transformation, UNS, and the digital factory? So while you select these responses, just think about whether you know these in concept, in theory, or you have seen it in real implementations, or you have been actual part of architecting and securing such environments. Okay, so 50-50. Oh no, it's changing. All right. So most of you are moderately familiar. All right, that makes it easy. So I'm going to end the poll now. Yeah. All right. So in an Industry 3.0 environment, it was all about automation of your manufacturing process. This created some digital data within your plant environment. Then came IIoT. IIoT created the ecosystem by digitally transforming the legacy manufacturing business to a business filled with smart connected things. That led to digital transformation initiatives, and that was all about going from manual or paper-based processes to an integrated digital processes. So digital transformation is about transforming the way manufacturers operate their business or used to operate their business by leveraging data they generated every day, but never really consume it in real time. So if it's transforming the way manufacturers operate their business, shouldn't we, as security professionals, be transforming our security strategy accordingly? We're going to talk about why later on. Whereas in Industry 4.0, what we did was we digitally integrated and uh, performed the automation of business processes. This created some information which is actionable. So on the left-hand side of your screen, it's a manufacturing process flow that almost every manufacturer goes um, through this cycle. Since you guys are moderately familiar, I'm going to skip talking about the manufacturing life cycle, but in the Q&A session, if you want, then I'll revisit that. On the left-hand side of your screen is the layers of automation stack. It's a functional model. And then in Industry 3.0 era, what happened was that we build a hierarchical point-to-point approach to connect, integrate systems like your PLC to HMI, HMI to SCADA, SCADA to MES, ERP, and so on and so forth, which was good in isolating machine controls from the internet for security purposes. However, it led to complex integration challenges. Each system had unique protocols and data formats requiring costly custom connections to be built. These were tightly coupled. It made changes difficult. Data transformation was very slow, hindering real-time decision, and the architecture didn't scale well, which created data silos and provided fragmented visibility across your plant floor. This complexity slowed innovation. It increases the cost for manufacturer, and it limited their agility. And we have all seen attacks and risk being exploited at almost every layer of this automation stack. Whether it's PLC, we have seen attacks against PLC, we have seen attacks, ERP systems, CRM, and so on. Moving to 4.0 environment, digital transformation initiatives were business driven to solve the 3.0 challenges that we talked about in the previous slide. Unlike your legacy manufacturing organization, a 4.0 organization is a fully integrated business made up of digital factory where everything is plugged into a network. The layers of the business are integrated and they operate based on data information from other layers in real time. The stakeholders involved know the current and future state of the business in real time. It leverages machine learning AI type of technology to collect and analyze data and information. Machine learning predicts the future based on the past pattern and the current state. And then your AI recommends operational adjustments to your plant flow to improve future outcomes, on which stakeholders execute or decide not to execute any recommended operational adjustment. Obviously, there were security concerns with such an environment, and it seems to expand the attack surface with connected devices across all layers of automation stack. So initial implementation of IoT, you saw people connecting devices, physical devices directly to the internet, and it was not an edge-driven architecture. So instead of building point-to-point integration, a new hub and spoke type of architecture was developed and termed as unified namespace. It's some sort of a broker-based technology and an edge-driven architecture. As security professionals, we must assess the risk of these different architectures and develop security programs that supports both the current and future architectural solutions. With this foundation, let's explore how 4.0 leverages UNS and IIoT architecture. So what is unified namespace? You can think of it as a single source of truth for all data and information across the business, across all nodes or system in a factory. It's the structure of your business and all the events within it. It's a place where the current state of your business lives, your production data lives. It's a hub through which all the smart things in the business communicate with each other, and it's the structural foundation on which all your digital transformation initiatives are going to build future solutions. If we use the software terminology to explain this, essentially what UNS is few components, a UI through which people input or extract information from, an API through which we retrieve data from the backend and put it into the UI or vice versa, and a backend database like SQL or something. And the combination of this with the master data model gives you what UNS is. Why business needs such a namespace? Because of scalability needs, normalization of the data, because they want to add context to that data, the machine data that all these devices generate, quick time to value for the business, agility, and of course, from a security point of view, this was important transition. The namespace is the next evolution of your ISA 95 foundation by cutting out the middleman for point-to-point links and replacing the rigid hierarchy by using ISA 95 Part 2 as your master data model to standardize naming convention and data repository, prioritizing information exchange that could be accessible by all systems and devices. The data and information in the UNS is organized to reflect the business and its business processes. So it's like a folder type of hierarchy where you have like an enterprise, site, area, line, cell. So what comes with it is that we are providing data out of the factory floor to a lot more use cases, to a lot more business professional within the company, as well as maybe to your suppliers and customers for that matter. For example, R&D, quality, asset maintenance, various project management functions. You may be trying to reduce, for example, power consumption and regulatory requirements by gathering this intelligence from your plant floor. Essentially, all business functions that never had access to real-time data or data from the factory floor is what UNS provides. How does it communicate or how does it work? It's implemented using common IoT protocol, for example, MQTT, and leverages some minimum defined technical requirements. Now you might have scenarios whereby you have legacy equipment that does not talk to MQTT directly. Doesn't matter, you can have integration via gateway that converts that protocol into the standard that you have defined as a minimum technical requirement. And then using some sort of a broker-based solution, UNS uses some publish subscribe model that enables devices to publish data to relevant topics in the pre-screen, enterprise, line, area, cell, and the system subscribe only to the data that they need. So all assets that are producer, like inputting data or generating data, and consumers taking the data are treated as a node in the ecosystem. This approach reduces unnecessary data traffic. It accelerated data flow, simplifies the changes because components are loosely coupled. You can bring in a device from the plant floor into this UNS architecture and take it out whenever there's a business requirement. UNS supports real-time organization-wide data access from plant floor operators to your executive, which helps them make faster business decisions. So understanding these limitations from 3.0 and then benefits of UNS is critical for designing a secure, agile digital factory. It's in the last presentation, somebody asked like, oh, so we eliminate in the previous diagram that we eliminated DMZ. No, we are not eliminating DMZ. We are architecting a solution that it can work with that segmentation in mind. So it's a distributed architecture, can be designed for horizontal or vertical distribution. It's more act like a fabric. This distributed architecture is achieved with bridging horizontal publishing and then store and forward from the edge. The architecture can be designed to avoid any single point failures. For example, you can have a UNS built for your single production line. Then you can have a UNS for your site, and then you can have a UNS for your enterprise where every factory is pumping in data. So the way data is acquired and transformed into information has fundamentally changed, both from an integration technology as well as from standardizing the information model. And it goes through an iterative cycle. To explain this, here's a model to let you know and understand how physical machine data goes through these cycles to become actionable intelligence in the digital world. So the data flows through the connect stage, where we interface different devices, sensors, and convert into formats that we can understand. Then we collect using protocols, message broker, and technology that supports open architecture. It's lightweight, it's not heavy on the network, and support report by exception, meaning like only the changes travel on your network, not the entire data set. Then we normalize, standardize, and add context to the data and store it somewhere. And then we analyze and visualize the data to process the data to find patterns, perform analytics, drive business intelligence for making informed decision. This is where how OT data meets IT style of data security and governance. Have you ever wondered why you keep hearing the term IT and OT converging? So hopefully it gives you some idea. We'll come back to this flow in the next session. Moving on to the next question to tackle is, what do we do for designing and securing such network architecture? Which architecture reference model to follow? Or we simply rely on solution architects to suggest and then try to secure it. So having looked at different models like Purdue, your other various organizations that have proposed industrial models such as Industrial Internet Reference Architecture, RAMI 4.0, or your zones and conduits model from ISS 62443, which you can still apply in the context of 4.0 architecture. These models are broad in scope. They describe architectural concepts, viewpoints, stakeholders, and relationship, but they do not necessarily describe the solution architecture for 4.0 environment. I was having these challenges last year. Secure came out with this paper called IIoT System Implementation and Certification based on ISS 62443 standards. It still does not give you all the answers, but is a good start because all these 4 use cases that are presented here gives you a bit of a good understanding how you secure and architect the future manufacturing environment. The closest I've seen is the paper by Biasi, Hitting OT and Modern IT, where he declared that a decades-old position, and this represents, according to him, the next evolution from the hierarchical Purdue model toward a distributed, interconnected device or event-centric rather model. So I'll highly recommend, if you can get access to this paper, you should read this one. So second poll, please, is the architecture that you often see being published online. Is it 3.0 or Industry 4.0? This is an example architecture defending OT with attack reference architecture. I'm not sure if you can see the slide. Maybe I can zoom. Not sure if you can.
It's pretty clear, Yusuf. That's good right there too.
All right. Yeah, sounds good. So can we have the poll number 2, please? If not, then we'll move on in the interest of time. Or you can simply type in the chat. All right, we have a poll. Okay. So while we are waiting for the poll results, coming back to our 3 type of manufacturers that we talked about initially, I needed to adopt some sort of a framework methodology whereby the request from each of these asset owners was not to follow or comply against any standards, but rather to ensure the cybersecurity program provides enough maturity and essentially leads to compliance with some sort of a standard like ISA 62443. Both. Oh, that's interesting. Yeah. Please put in the chat why. All right. So I came up with this 12 foundational steps for the enterprise cybersecurity program. I call it IT/OT Security Dozen, initially OT Security Dozen, to provide the very foundation required for establishing and running a successful program. It can be run as a standalone program or as part of your broader ISMS initiative as a subset. All within IT/OT cybersecurity awareness piece wrapped around it. So essentially divided into 3 buckets: securing the business. We talk about assessment, reviews, discovery, policy governance, risk management, supply chain, and all that. Then you have the security controls implementation in the second bucket, where we talk about detective and protective controls to be implemented. And then third one is security operations or secure operations, where we talk about the monitoring, incident response, backup, and all that. So what was under the hood of this approach was to include and make sure that I factor in all aspects of the business, from understanding who the stakeholders are that are involved and the relevant organizational context in terms of org structure. This is a McKinsey model, 7 layers of McKinsey model. I didn't have a better picture to represent this, so I used that, but I did not use that model, just to be clear. And then understanding the life cycle of the manufacturing stages, and then the physical process associated with the life cycle. Once you have identified those elements, then you start inventorying the business across each layer of your automation stack, from your CRM to PLC, and then essentially looking into the OT project lifecycle stages the organization has adopted, and then identify and embed missing security activities. The goal essentially was to identify preconditions and objectives, then analyze some associated risk, then derive a specific security requirement, and design and implement your security controls. One thing that's often overlooked is the in these engagement was like, okay, many of but they often missed assessing the risk to operations because certain OT operations were dependent on IT systems. And we have many incidents in this industry where this has occurred. And I'm not going to talk about that, but I can give you example later on. So coming back to those 3 types of manufacturing organization, this slide represents a partial roadmap for the security program. Again, divided the program into 3 parts. Each part have approximately 5 goals, totaling around 12 to 15 goals, and spread across 2+ year journey. So you had like the strategy, then you had like the roadmap, and then you have all these activities highlighted on the screen. For most Industry 3.0 organization, this was a linear approach, for example, for type A and B manufacturer. But for the ones that were advanced in their journey and had adopted agile methodology, they ran these projects in 1 to 3 month sprints in parallel by identifying dependencies on each of these projects in case of the type C organization. Many of these initiatives faced hurdles, obviously, from different stakeholders, where there was lack of commitment and or clear ownership, while others made progress where they had agreed on shared values and requirements in advance, and the mandate came from top. A common recommendation I had is not highlighted on the screen is the initiation of 90-day remediation program for quick wins and fixes after discovery and assessment exercise that doesn't require any heavy investment. As it turned out, it was reducing the attacks.
Yusuf,
So
we had one question here, and as we got I think 4 minutes to the end, I want to make sure we get this in. So this is from Lakshmi. What is your take on digital twins and how to secure the digital twin?
Well, it's a very long question. Most of the digital twins I have seen does not provide real value, or at least in my experience, meaning that it represented something of the state of your manufacturing environment or something point in the past, not in real time. So that's one fundamental issue that I've observed. I might be wrong because I have not seen many environments that have adopted digital twins. But the concept of UNS cannot be equated to digital twin. It's a slightly different concept. So if you are asking it from that perspective, then I should clarify that. Other than that, I have not much insights on the digital twin aspects of
Okay.
things.
And then we have 3 minutes remaining as well.
Okay. So coming back to the data flow. So from a security point of view, we need to embed certain security controls at each stage of the data flow lifecycle. We need to ensure using secure methods for connectivity and collection, using secure protocols, for example. And then we probably need to do encryption and certified connections to mitigate any security concerns. Because you are plugging in, plugging out of nodes in the ecosystem with your UNS. So you need some sort of a security mechanism to be able to ensure that the right devices are connected. In the store, analyze, visualize stage, we are more concerned with the data classification, governance, access control, and protection, both at rest and motion. And then for the find data patterns and report stage, we are concerned around the same things as in previous stages, but in addition, now we have to cater to cloud and AI related security elements as well. So data governance would become an increased importance for these environments. And last but not the least, security, identity, and access management will play a crucial role in the coming 4.0 or beyond era. So as your human identities and non-human identities exist at each layer of your industrial automation stack, from cloud to factory floor, identity solutions, though very common in IT environment, now are becoming essential controls across your OT network as well. So advanced solutions like threat detection and response for identity are important, gaining momentum for cloud and enterprise level, but they are not commonly used in lower level of your automation stack, except in few advanced settings. So however, the industry move towards 4.0 and beyond, we'll likely see these technologies to be adopted by the organization. So the ultimate goal is to ensure that we have business inventory documented along with the manufacturing workflows, identified crown jewels, their risk maturity understood, and then you have a secure reference architecture with appropriate set of controls in place. Aligned with some industry standards, and then the overall that provides defense in depth for your organization. I hope this has been of some value. Thank you, and feel free to reach out or ask questions. I hope you enjoy the rest of the great presentations coming up.
This was wonderful.
Questions in the chat?
Thank you very
Thanks,
much. I don't think there were any other questions in the Q&A or in the chat here. I think we're good there. Thank you very much for all the information and a amazing presentation. Really appreciate it, and as I'm sure the audience does as well. That ends our first half day for this track. We've got a recharge and break virtual networking session, so you can go over to the lobby, and then next up will be the ecosystem panel. And that starts at I believe 1 p.m. So thank you very much. Thank you, Yusuf, and everyone. Thank you, all the
Thanks,
attendees
Paul.
as well.
Thank you all.